Okay, I'm back, and now we are going to look at properties of minerals. So how do you identify minerals? So if we go to A, the first way of identifying a mineral is by its luster. Luster is how the mineral reflects light. There are actually many different kinds of lusters, but all you need to know for the laboratory exam is, does it reflect light like a mirror? So that's going to be metallic luster, or does it not? So there are only 3 of your minerals, samples 1 through 20 in your box, that have a metallic luster. So go ahead and pause me and see if you can find out which ones they are, and then write down their names below. Okay, we're back. So what did you think that they were? Well, I hope that you definitely chose sample number 16. So sample 16 is galena, and this is where we get lead from. And you also notice it's very dense, so that's another way of identifying galena. Okay, then you should have also have chosen sample number 19, which is called magnetite. Take a guess. What do you think magnetite can be used for? Magnets. So this has a lot of iron in it, and it's naturally magnetic. So the ancient Chinese used this to make compasses with. Okay, then you also have sample number 18. So this is called peacock ore. And notice as I turn it that it changes colors. So those were the 3 that had metallic luster. Everything else in samples 1 through 20, your minerals, have non-metallic lusters. Okay, now let's go down to part B, and it says the hardness. So hardnesses of minerals also identify them. So you have the hardness scale goes from 1 to 10, 1 meaning the softest mineral there is, and then 10 being the hardest. So the softest mineral is talc. You don't have talc in your box. It wouldn't make much use for me even to put talc in the box, because within a matter of weeks, with students feeling it, they would crush it. So talc is used in talcum powder because it's so soft. Now we do have gypsum though. So gypsum is going to be sample number 13, and it has a hardness of 2. And notice that your fingernail has a hardness of 2.5. So that means that if you work at it, you could scratch gypsum with your fingernail, but gypsum would not scratch your fingernail because your fingernail is harder than what gypsum is. Okay, then you do have calcite. So calcite is sample number 11 in your box. And you do have feldspar. So feldspar is samples 2 and 3. You do have quartz, so that's sample 1. And doggone it, we don't have any diamonds in the box. And if we did have diamonds in the box, they wouldn't be in the box today because students would have stolen them. So diamond is the hardest of all of the different minerals. Sounds like a good test question, doesn't it? Oh, it's already on there. All right, which mineral is the hardest? So it's diamond. Okay, let's go on down to cleavage. Okay, the atoms that make up a mineral line up in specific patterns. So they have the atoms are in a certain, are hooked together in a certain way inside of the mineral. When the mineral is broken, it will break along planes of weakness in the crystal. These are going to be called cleavage planes. So I just want you to look at this picture. that shows different kinds of cleavage and then the different kinds of minerals that have it. You can look at, for example, halite, which is sample number 12. And you notice it makes cubes. Okay, little cubes. Even if you crush this up, grains of salt will still be in the form of a cube. So that would be its cleavage planes that goes with it. But take a look at calcite, which is right next to it. Calcite, if you look at it, you would immediately think it's a cube, but it's not. You see how that the bottom part of it is sideways, but the other part is at an angle. It's making an angle to it. That's not a fluke. So it's not a cube. It's going to be called a rhombohedron. And so that is its particular cleavage planes. Now you won't need to know anything about cleavage planes for the exam, but it is very important to be able, when you're trying to identify minerals. Okay, then crystal shape. So again, the atoms inside a mineral determine its crystal shape, and so there again is halite, which is table salt, and then calcite is right next to it. Now you should know the answer to this one. Look at the minerals halite and calcite. Which one has crystals which makes cubes? I just told you. So back up the video, but I think you can just see from those pictures which one's which. Now on E it says physical and chemical properties. Some minerals have a physical property that allows you to be able to identify it. For example, we said that magnetite is magnetic, so it would attract a paper clip, for example. Other minerals have a chemical property. Halite tastes salty, so you probably don't want to do it, but you could take this crystal of halite and lick it, and it would taste salty, just like salt. That would be a chemical property of halite. Calcite, which is sample number 11, is going to react to acid. Now, I can't really do that for you because I don't want to get acid on my computer. However, if you'll go to Google and type in pouring acid on calcite and then go to videos, you're going to find a picture of it. So you could also do it with vinegar. So if you took some vinegar and put it on the calcite, it would fizz very slowly. So that if you were to come back and look at it in an hour, it would have some bubbles. So vinegar, because it's an acid, would eat away at calcite. Now this is very important because calcite is going to be in limestone, the rock limestone. And then limestone dissolves when rainwater gets on it, because rainwater mixes with carbon dioxide to make carbonic acid. And when it eats away at the limestone, that's where caves come from. So it says pour some acid on calcite and explain what happens. So I encourage you to go to a video of that because it is pretty interesting looking. So I'm going to stop the video here, and then when we come back we're going to look at the silicate minerals.